Hello. Today we're going to be looking at the area sine rule, which is a way of finding the area of a triangle when one doesn't know the height of the triangle. Now traditionally we have used this formula, and I'll just like to draw it out and remind you of it. If I've got a triangle ABC, and this, we know this length here, we can call that B, and we have a knowledge of the height, we know what the height is, then we can say that the area of triangle ABC is equal to 1/2 the base B times the height. I'm sure you've all seen that formula and heard of that before. Now what we're going to do is from this formula, we're going to develop another formula that uses the angles. Now before we do that, I'm going to introduce to you a new way of labeling triangles where you don't have a right angle triangle, a right angle in it. So what we do is we label the side opposite the angle. So this is A here, we label that capital A. The side opposite will be small a. This is angle C here, the side opposite that angle C will be small c, and I've already labeled this one as B opposite B. Now if I knew, for instance, what this angle over here was, theta, then I'm sure you'd all agree with me that we could write that, we could say that the sine of theta is equal to H over C. Is equal to H over C. And we could then use this or change this around. We could say, well, H, the height, is equal to C sine of theta, like that. Now if I take this H and I see that I've got an H there, I can replace H by C sine of theta. So instead of writing it like this, I can write this as 1/2 B, and then instead of writing the H, I'm going to write the C sine of theta. And then we have a new formula. This is the area of triangle ABC is equal to 1/2 BC sine C. If we change these sides around, we can actually develop this formula with the different sides and angles. This obviously here, this theta, I'm going to change, and I'm going to put, instead of the theta, I'm going to put in A, because we are actually dealing here with A. It was the angle A that was equal to theta, so I can use that. We can also say that the area of triangle ABC is 1/2 AC sine of B, or it's 1/2 AB sine of C. These are the formulas that you can use. Now these will always be given to you. You don't actually have to learn how to do the proof, but I thought it would be interesting for you to see it. But the important thing really, and it's quite interesting for you to see it, that this formula always works if you have the side, the angle, the side. So it always works when you've got the two angles that make, the two sides that make up the angle. You can always use this formula. It will fit in. Now let's use an example for this. Let's do an actual example, and you can see how in practice it can work. So let me just pull it down here, and I'm going to use this example over here. Say I've got this triangle over here. Say I've got this as an example. Say I've got this triangle like this, and we've got A, C, and B. Now if this angle here is 28 degrees, and this side is 15 centimeters, and this side over here is 11 centimeters. The first thing I always need to do, I'm dealing with a non-right angle triangle, is to label my triangle according to the angles. So I can label this as A, this is C, and I've got angle B. Now, the three formulas I've got, if you remember them, the area of triangle ABC, I'm just going to write them up again because it's good that you see them. A half AB sine of C, or a half BC sine of A, or a half, which is the last one, AC sine of B. You notice there that there's a pattern here. It's always the two sides and the angle that isn't included in those two sides. What you do notice here is that we've got the situation. We've got a side, we've got another side, and we've got the angle in between. So we can actually use it. And because I've got B, I'm going to use this formula over here. I've got the A, I've got the C, and I've got the B. So we can use that. Area of triangle ABC is equal to 1/2 times 11. Put your numbers in brackets when you're substituting in, and then when you're going to have the sine of 28 degrees. Now you're going to calculate that using your calculators, and you will get, when you do that, an answer of 38.7 centimeters squared. Now we usually do it to three significant figures. In this case over here, I have got two significant figures, two significant figures. So perhaps a better way of writing would probably have been to say 39. This would have been fine though. Don't forget to put your unit in. This is very important because in mathematics, whenever we're doing calculations, we want to put in our units. It's a squared term because we are dealing with the area. So just to recap on this, it's a formula that we use when we don't know the height, where we've got some angles and sides. We need to have, for it to work, I'll use another one. If I for instance had this side, and this angle, that would work. You need the two sides that make up an angle, and that works for the sine rule. Remembering the labeling, we label according to the capital letter for the angle, and opposite we have the small letter for the side. See, we have C and C, B, this would be small b, B, and B. So that is your area sine rule. Very simple formula which you can use. Thank you very much.